Hi, I'm Dr. Tom Gerard, and in this short video I'm going to be going through some of the things that you should learn in your very first chapter of your statistics class. Some of it you may already know, and other may be completely new to you, but mastering these few little things in the very beginning is going to help you going forward in your class. Now, first of all, what is meant by statistics? Well, statistics is more than just gathering a bunch of numbers. In fact, you'll see in this definition, in this particular book, it has a lot of verbs in there. The science of collecting, organizing, presenting, analyzing, and interpreting data to assist in making more effective decisions. So you'll see that there's a lot of things that's involved in statistics, and that's why the course sometimes seems like it's really hard, because there's a lot of stuff going on there. And again, getting these few things that we're going to cover here down is going to help you going forward. So the next thing you want to know is that there's two types of statistics. One is called descriptive statistics, and that comes from the word describe. We're just describing things. And then an example, if I'm going to go to a store because they're having 20% off. They're having 20% off, and that's just describing. It's not predicting anything about the future. It's really not talking about anything about the past. It's just describing that I'm going to save 20% if I go there. You can use percentages, and we see a lot more of that as we go through the course, but we're really describing it. Well, twice as many men than women like football, or twice as many women like to shop at the mall than men. I don't know if all that's true. I'm just making it up as an example. We're just talking about things and we're describing them. Now, the other type of statistics is called inferential statistics, and it comes from the word infer. I'm going to infer something about the future. It's going to estimate. We're going to estimate something about the future, or about a group of people or a group of things called the population. We're going to infer that. It says a method used to estimate a property of a population based upon the sample. Well, that's a lot of fancy words. When you really don't know, we haven't even talked about what's a population and a sample. Well, again, maybe you already know that. But that's one of the things that's very important when we start talking about inferential statistics. Well, the population is the entire set of individuals or objects of interest. We're talking about the entire set. Now think about this. If you're a college student, an entire set could be all of the college students at your school. It could be all of the college students in your class. It could be all of the college students in the United States. It could be all of the college students in the world. Every one of those could be a population that you're interested in. Remember, inferring something about. I want to know something about the entire population. Well, if it's your class, maybe it's real easy to learn something about your class. Maybe you have 25 or 30 people in there, and that would be easy to gather data about. But what if I was interested in every student in the school? Well, that would be a lot harder. I mean, maybe you could do that depending on how big your school is. But then as you get in, like, well, what about all the college students in the United States or all the college students in the world? Well, there's just no way that you could ever poll all those people or study something about them, gathering data. You'd have to use a population. And that is a portion or part of the population of interest. So here's a picture of all these cars, and we're going to take a sample. We want to know about cars in this, maybe this little diagram, something about cars. And we can't test drive every car in the whole world, but we could take a sample of those cars, see, and we could look at them. If this was all of the college students in the United States, we could take a sample. So basically what we're doing when we're talking about inferential statistics is we're talking about taking a sample of a larger group so that we can make some kind of decision or idea about the bigger population based upon the sample. And we cover that in great detail in later in later chapters, because one of the biggest problems you have when you talk about mistakes that are happening in statistics, and one sometimes when things don't work out, it's called sampling error. I've gathered the wrong sample. I didn't have enough people in my sample. I didn't have enough, and I say people, but it could be other things that we're studying. You know, maybe you're a drug manufacturer and you're trying to come up with the right amount of milligrams to treat a particular disorder. So sample error is very common. Okay, so we talked a little bit about that. Let's go back here. So that's what is statistics. Now, the next thing we want to talk about is variables. Now, variables is anything that we're studying. Okay, so, and a variable could be just anything. Like I said, it could be college students, it could be the cars, it could be how many widgets is the machine putting out, it could be how many people are going to the doctor for a particular disorder. It could be many things. So let's talk about variables real quick. In this case, we're going to talk about two, again, now these are variables, two basic types of variables. Variables are something that we want to study. There's qualitative and quantitative. Now these words are very much the same, and if you're not careful, you can twist your tongue, and you can get them backwards if you haven't been exposed to it. But think about, let's look at this. There's qualitative and there's quantitative. So think about quantitative. That's something I can count. Quantity. What is the quantity, right? Well, here's an example. A variable that is reported numerically. How much money is in your bank account? How many gigabytes does your computer hard drive have, right? Or your cell phone plan, how much did you use last month? The number of people. Quantity, I can count them. Now, qualitative is just the opposite. So it's easy to understand quantitative first, because then qualitative would be just about everything else. An object or individual is observed and recorded as a non-numeric. Okay, now what of that? Well, we got gender, we got, this says beverage. What kind of beverage preference do you like? You know, alcoholic, non-alcoholic, soda, coffee, tea. How about eye color or any other color? One of the ones I like to use, we talk about, you know, the different kinds of flooring. What kind of flooring do you have in your house? Do you have tile? Do you have hardwood? You know, do you have carpeting? So those are all things that we can't count. Those are called qualitative variables. Now that leads us to the next thing that we need to know about. And that is, so we're talking about types of variables, qualitative and quantitative. In fact, let me go back to that. I just want to make sure I covered the chart. Here's a little chart. You can see types of variables, qualitative, brand of computer. Oh, do you got an Apple or an HP, right? Or a Chromebook? Marital status, hair color. Okay, we don't add hair color, but we can, you know, add up. In other words, we can't put it in numbers. Types of variables, quantitative, and then within quantitative, there's discrete and continuous. And again, we'll cover more of that in detail in a future course, but discrete, you know, how many children are in your family? You don't normally have 3.2 children in the family. It's discrete because there's an absolute number, where continuous could be, you know, it could be broken down to decimals in very small amounts. So we'll go back to that another time. But we were talking about variables and how we name something, which like the flooring or, you know, the color of something. And so that takes us to what we need to know, the level of measurement. Now, some of this seems very simple, but quite frankly, when you get into doing your actual research in statistics, you find that many beginning students have a problem separating these different types of variables, and a lot of it has to do with what level of measurement. So there are 4 levels of measurement. There's nominal, ordinal, interval, and ratio. Okay, the level of measurement determines the type of analysis, statistical analysis, that can be performed. Nominal is the lowest level of measurement. That's ones we were just talking about. Nominal comes from the word name. I'm going to name it, right? What color of hair do you have? What kind of flooring do you have in your house? That's nominal. Data is recorded at the nominal level is represented as labels or names. They have no order. They can only be classified and counted. In other words, blue is not more of something than red or yellow. You know, they're just naming something, okay? So then let's go to the next one. If I can figure out how to do it. This is a statistics class, not a presentation. So let's talk about ordinal now. The ordinal level is things are in order. Well, the kids had a relay race, and the first contestant came in, let's put it this way, Johnny came in first, and Sally came in second, and Joey came in third. Okay, we know the order that they came in, but we don't know, for example, we know they came in first, second, or third, but we don't know how fast one of those students came in or those runners came in over the other one, right? Next level of measures ordinal. Rankings are known, but not the magnitude of the differences. This is the one where you'd go home and you tell your mom and dad, I got a really good grade. I got third in the class. And then, you know, think, wow, that's really good. They probably got 30 people in there and you came in third best. You go, well, no, there was only 3 people showed up today because it was really cold or something, you know. Anyway, so you came in third, and that sounds maybe like you came in the top 3, when in reality maybe there was only 3. Or maybe that if you were running a race and the first place person, you know, they ran it in, you know, 30 seconds, and then the second person came in 45 seconds, and then you came in 45 minutes, well, you're still number 3. However, the distance between 45 and 30 seconds is really big. But you don't know that in ordinal when I just say, oh, so-and-so came in first, second, or third. All right. So the next one we're going to talk about is interval. So you can see we're building upon this. You know, we're building upon. Data has all the characteristics of ordinal, which means we know which order, plus the difference between the values are meaningful. Okay, data recorded at the interval measurement or distance between the values is meaningful. Okay, so Fahrenheit temperature, when we say that, well, it's 75 degrees or it's 70 degrees, you know, we know that that is ordinal. Now, actually, we're going to talk about Fahrenheit temperature. Well, this is interval, yes. So we know the interval. It's what we call scale data. How about your dress sizes, you know, or your pants or your shoes? We know that the size 10 shoe is bigger than the size 8 shoe by 2 sizes, right? Whatever size is measured in. I don't know about shoes, but you get the picture. We know that it's ordinal, and we know the distance. So if we were in that race, we could say, well, you know, Johnny came in first, and Sally came in second, and Billy came in third, and they each came in 30 seconds after each other. And so that way you'd have an interval where I know that the order they came in, but I also know that they were 30 seconds apart. Okay. Now, one of the things I will say, let's go back when we're talking about interval. It says Fahrenheit, and it talks about no natural 0 point. So when we talk about how cold is it outside, if we're in the United States and we're using Fahrenheit temperature, you're going to say, well, it's 0 degrees. Now, 0 degrees does not mean that there's no temperature. Right? It means that it's cold, you know, it's 0 degrees. And so in interval scale, 0 has a meaning. There's a meaning there, right? It's 0 degrees. I think that's why they put the dress sizes, because I don't buy a dress, but I think there's a size 0. I don't know. I assume there is because that's their example. So it has a meaning, what size you wear. Oh, I have a 0. That's the, petite girl. All right, so now the next one is, ratio. Whoop, let's go back. Ratio level. And ratio is the highest level of data. Data has all the characteristics of the interval scale, and ratios between numbers are meaningful. So this is a lot of times when you have decimal numbers and you have what we see a lot of times in finance, financial ratios, things of that nature. Now, the interesting thing here where it says the 0 point represents the absence of a characteristic. So you'll see here examples, wages. How much money did you make last week? Well, if you said 0, that's not any money. It's 0. It doesn't exist. Changes in stock price. Was this the same as it was yesterday? There was no change. That means 0, nothing, right? Whereas remember when we talked about interval and we talked about the Fahrenheit and we says, well, 0 really is a temperature. How about your height? Can you be 0 height? How tall are you? I'm 0. Well, that really doesn't mean anything. Okay, so let's take a look. There's a chart here, and these are the things. Now, there's many videos and other sources you can look to look at these. But sometimes you think about if I start saying things and you try to put them in place. So think about we kind of already talked about just naming something. What kind of apples do you like? Do you like the Golden Delicious or the green ones or the Granny Smiths or the whatever kinds of apples? Again, what kind of flooring do you have? This would be one that we see a lot when we're talking about descriptive statistics, and we're talking about Democrats and Republicans and independents and libertarians. That's all nominal. Think about ordinal. Here's one for you. How do you like your steak done? Do you like rare or medium well or well done? Well, we know that that's kind of ordinal. We don't know that my rare steak and my rare steak and my well done steak, that the well done is cooked twice as long. We don't know that, because if we did, then it would be interval. But we don't. We just know that it's cooked more, right? So data are ranked. Interval, meaningful differences. Now, one of the things that you see a lot in research of all types in all different fields is what you call a Likert scale. You've probably taken those surveys where it says, do you agree? Do you strongly agree? Do you disagree? Do you strongly disagree? Or are you neutral? And those are called a Likert scale. And there's been debate among researchers, and I'm not really going to get into it because right now it doesn't matter to us, because I'm just bringing it up, so I want you to think about it, right? Think about it for a moment. So is the Likert scale ordinal or is it interval? Because if I say, well, I strongly agree, well, that's more than agree, and it's more than neutral, right? But we don't know how much, do we? So you might say it's ordinal, but many statisticians and people in research treat the Likert scale as interval data, when in reality, the better way to ask the question, and this is the way I recommend to my students on their when they're doing research, is I say, don't use a Likert scale. Say, well, on a scale from 1 to 10. If you say, well, on a scale from 1 to 10, how do you like this or that, or how do you feel about this or that? Then I know that, well, 8 and 9 and 10, that there's an equal amount between them in my mind at least, right? I could go, well, is it 8.1, 8.2, 8.3, or 8.11, 8.12, and so forth. You could break it down really small. But generally speaking, people think, when they think between, on a scale from 1 to 10, or even 0 to 10, I know that 10 is twice as much as 5, right, is what we're thinking. Whereas if you say, well, is strongly agree twice as much agree than neutral? No, well, that doesn't make any sense, although sometimes it's treated that way. But for now, just be thinking about those kinds of things, because in the future, when you start doing your research in this course and others, you're going to have to know the level of measurement. And quite frankly, it can be confusing. It really can, even though it seems pretty basic at this point. Well, the last thing that we have here, it talks about ethics. And I've gone for 20 minutes now, but we could probably have another whole, we could have a whole class in ethics, of course. But for ethics and statistics, we have a saying, kind of a funny saying that we always said is that, if you torture the numbers long enough, they'll say whatever you want them to. So we'll see, and most of the times when you're looking at the news, and you hear so many different things going on around you, you have a hard time knowing, well, what is true and what's not true. Well, that comes back to ethics in research. So the people may or may not be lying. They just might be using a different sample from a population, a different number of sample. There's also what we call confidence levels that we'll cover in a future course. Is my confidence really high? I'm really confident. Or am I spread out? Well, I'm kind of confident, right? So those kinds of things, are completely acceptable once you start getting into how the statistics are calculated. And people can deceive you without really lying. And so anyway, that's a lot of stuff that has a lot to do with ethics. But the main thing is we want to know that when we're reading research, specifically scientific research or what they call peer-reviewed journal articles, which is printed research, that is reliable. However, and the thing that separates peer-review research from just, some news reporter went out and did a story and came up with something, is the fact that they follow the rules of statistics. They follow the rules that if I'm going to say that this population does represent, this sample represents the population, I'm going to tell you how I came up with that. I'm going to tell you what level of measurement I'm using. I'm going to tell you what my confidence levels are. So when somebody reads the research, you can say, well, does this really apply to me or if I'm in this population and that sample's trying to talk about me? Those are the kind of things that you can look at in peer-reviewed research. You don't get that when you read the paper or hear something on the internet. Most of the time they might reference the research, and I encourage you to always go back to the original source, the original research if they're quoting research. A lot of times it's just made up stuff, it's trying to present their agenda. And you don't know any different unless you just go out and research it yourself. Okay, I'm going to be done now. Now, the one thing I do want to say before I finish is that these things that we're talking about here, and that we'll talk about in future chapters, is that this statistics is the same whether you're in business statistics or whether you're in psychology or sociology or botany or biology or any other course that you're taking where you're studying statistics or research. It's all the same. Okay, so we use it a little bit differently on what we're trying to study, but the methodologies are the same. And that's why when you do read research, they're going to try to follow the same procedure and the same rules, whether you're studying about something in medicine or technology, or whether it's, in business where you're talking about marketing or, analytics and things like that, customer preferences and those kinds of things. So it's used the same. So get these things down, whether you're in a business statistics class or whether you're in social science or some other field. It's all going to operate the same way, and I hope that this really brief video has helped you.